Recall that when doing the Claisen or the Dieckmann condensation, we usually want the base we use to match the leaving group of the esters. Now in this problem, one that is part B of a previous assessment, I guess we're getting bonus coverage here because here's the answer to that question. In this one, it doesn't matter, right? Which base we use is not going to have an effect. So why is that? What's special about this particular Dieckmann condensation that makes it such that we could use methoxide or ethoxide or isopropoxide? First, let's make sure we understand why this is the product. Notice that carbon 2 we can make into the enolate, and that enolate will attack carbon 8 to form the new ester, and it requires a little bit of rearranging of the structure to draw this right, but we've got the carbons numbered. You can figure out that mechanism on your own. What makes this one different is that both of these esters are intramolecular. So just as an example, let's imagine what would happen if methoxide attacked here. So if methoxide served as a nucleophile instead of just a base, how would the reaction change? Well, the methoxide would attack, push those electrons up, and that would give us the following product. Right? Remember that methoxide in this reaction can be a base or a nucleophile. If it acted as a nucleophile, we would make this tetrahedral intermediate. And when this tetrahedral intermediate collapsed, we can either kick out O- of the methoxy group or O- of the group that's attached. When these electrons collapse back down, it's actually going to be methoxide that gets kicked out most favorably because of entropy. When we think about this equilibrium of methoxide plus this, that's two molecules going to one. Going in the reverse direction, it's one molecule going to two. So this molecule is going to be entropically favored. And so we're not worried about methoxide acting as a nucleophile because it'll just get favorably kicked out. We could have done the same thing with either of the esters here, and the same thing would have happened. If methoxide added to either of those carbonyls as a nucleophile, it would have simply been kicked out to regenerate this diester. So it's for that reason that our choice of base in this Dieckmann condensation is unimportant, whereas it has been in other Claisen and Dieckmann reactions.